Okay, so I apologize for the delay there. I have my audio situation figured out, I'm pretty sure. Okay. All right, so we are going to talk about finding values on sine wave charts. So this is actually just looking at a graph and interpreting. All right, so most of these, your graphs are already drawn, or you can find an easily drawn graph that you can already find the values for. This is similar to something that we did on the introductory activity. I think I only did that with sections 1 and 2 though. So anyhow, I want to talk about how we would find these values. So it's really important that we show all the values. So this says show all the values for which cosine of t is 1/2. All right, so first of all, we know that if we look on the graph here where cosine of t is 1/2, that means the y value is 1/2, which is going to be approximately right here. All right, I want you to think back to your unit circle. All right, so this is where you're going to have to come back to some of that knowledge. So if we know that right here is 1/2, and right here is 1/2, and right here is 1/2, and right here is 1/2, okay? So you'll notice that the graph cycles, so it goes, you see the red area? That's the first one, and then it just keeps looping over and over and over again. It keeps doing the same thing. So we have to account for that. This does not say what are all the values for which cosine of t is 1/2 between 0 and 2 pi. It says it wants all of them, so we do have to account for that. So we need to think about what value is this, okay? First of all, we know it's between 0 and pi over 2. All right, that's important. This graph has them labeled. It won't be like that. You're going to have to find your own. All right, so where is cosine of t 1/2? Well, if you think about your unit circle, or you draw your triangle, 1, root 3, and 2, okay? This is my angle pi over 6, and this is my angle of pi over 3, all right? I know that cosine of pi over 3 is 1/2, which means that this value right here is going to be, this value right here, the x value is pi over 3, okay? Now, the other one, you notice this cycle, this is a different value right here, right? Okay, because the second one here is a different place on the graph itself before it starts repeating itself, all right? So this value right here is going to be different, and I want you to think about this is between pi and 2 pi. It's actually between 3 pi over 2 and 2 pi. So if you think about where that is on your, we know it's going to be a cycle of pi over 3. Okay, that's going to be, you know that anywhere that cosine of t is 1/2 is a value of pi over 3. So where is it pi over 3 between 3 pi over 2 and 2 pi? This is unit circle stuff. If you struggle with the unit circle, this is not going to make a whole lot of sense. All right, so if you remember correctly, we have between 3 pi over 2 and 2 pi is right here. So what is our over 3 here? Pi over 3. All right, now just a trick, okay? This quadrant is 1 less than 2 pi. So 2 pi is 6 pi over 3, okay? So 1 less than that's going to be 5 pi over 3. So that's how I find this value. Now again, it's already written in my chart, but I'm showing you how to find it, okay? So I have these two values. Now you'll notice that the graph of sine will repeat itself every 2 pi cycles, right? So I can write this as t equals pi over 3 plus 2, now I'm going to use the value k, that's just what they use in the book, and this pi didn't show up very well, sorry, my board's not aligned, 2k pi. Now the reason I use this k says that for any multiple of 2 pi, this will work. Okay, so pi over 3 plus 2 pi is going to give me a 1/2 value. Pi over 3 plus 2 times 2 pi is going to give me a 1/2. All right. Now remember that we have two values, so we also have to account for the second one. T equals 5 pi over 3 plus 2k pi. All right, now I'm going to talk over this just a little bit, okay? I know I seem like I'm probably being a little bit redundant. If you get it, you can move on, fast forward just a little bit, that's fine. Okay, this is for those of you that are struggling with understanding how I'm getting my numbers, okay? You have to account for every value for which cosine of t is 1/2. So if you look on a sine chart, it cycles every 2 pi, okay? It's going to repeat itself every 2 pi. So I need to look for all the values between 0 and 2 pi that I would get 1/2. There are two places on this graph where it is pi over 3 and pi over 3. Then every 2 pi, it's going to repeat itself. So I need to have a constant, a value that I can multiply by to say every 2 pi it does that. That's what this does. So this would go, it would be 2 pi, 2 times 2 pi is 4 pi, 2 times 3 pi is 6 pi, and so forth and so on. So that's why this answer is going to have another variable in it, because it's accounting for the fact that it's going to repeat itself over and over and over again. This k is an integer, which means it also accounts for negative values, negative 2 pi, negative 4 pi, because it cycles backwards too. All right, so this is if I'm doing it for, I just keep saying sine. I'm sorry, this is the cosine chart. I apologize. It still repeats itself every 2 pi, but I was thinking sine. So this is a cosine graph. So my apologies there. All right, let's go on. Let's do another example. All right, so here's another cosine chart. This works. It works the same way for sine. You're still going to repeating itself every 2 pi. And again, the last one, I think the example was supposed to be a sine value, and I apologize I didn't put it up there right. So, but sine works the same way. So we'll do another one though with cosine. All right, so it wants to know where is cosine of t negative square root of 2 over 2. Well, first of all, since it's negative, we know it's going to be below the 0 line, right? And so that's going to be somewhere here. I'm just going to draw a line. Right? It doesn't matter where this line is. All right, we'll pretend it's straight. Okay, but it's going to be below the 0 line. And I have to think about where is my value root 2 over 2. So I need to think about a chart, right? Where do I have ones that are root 2 over 2? 1, 1, root 2. These are pi's over 4s, right? All right. Now it's also negative, okay? So this is going to be important because the first place that it hits is going to be between, it's actually, this is not quite accurate. It should be somewhere right around here because this is pi over 2. It needs to be after pi over 2, okay? So it's going to hit here. So this value is not pi over 4. Pi over 4 is actually here, okay? But this is going to be the second one. So what's the second one? It is 3 pi over 4. All right, and I know this because it's 1 less than pi, which is 4 pi over 4. All right, where we talk about quadrants, okay, it's in the second quadrant. It's 1 less than pi. Now the other quadrant that it's going to be negative is actually in the third quadrant here. So that's 1 more than pi. So this value is going to be 5 pi over 4. We do it the exact same way we did the last problem. T equals 3 pi over 4, because it's going to cycle, remember, it repeats itself, okay? Plus 2k pi, because it repeats itself every 2 pi. And then t equals 5 pi over 4 plus 2k pi. All right? So that's it for that one. Now we need to talk about tangents as well. Now tangents are a little different. Oh, there's my sine. I must have my notes all mixed up. Let's do the sine example. Okay, we have time. So sine of t, it wants to know where is sine of t1? Well, this is actually an easy line to graph. Okay, it's going to be right here. Okay. And these ones are actually easier to find. We don't even have to think about unit circle. Okay. Now, how often does it hit 1 in a cycle? Okay, if it starts here and it goes from 0 to 2 pi, okay, it actually only hits it in one place. So this is only going to have one answer. So it only hits it where it's pi over 2. So it's t equals pi over 2 plus 2k pi. Because every cycle, pi over 2 plus 2k pi, it's going to hit at the one value. Same thing if we go backwards. This k can be any integer, negative or positive. Okay? So that's that one. That was an easy one. Alrighty. Now we can look at our tangents. Okay? Now tangents, I want you to look at how often does a tangent cycle. Okay? Tangents are probably a little harder to identify. All right? Tangents cycle every pi. All right? They don't cycle pi. They don't cycle every 2 pi. If you notice, now I know it starts in a weird place, right? It starts at negative pi over 2. So negative pi over 2 to pi over 2. That's a cycle of pi. So it goes every pi. It's going to repeat itself. So when we're going to add, it's going to be k pi, not 2k pi. So this one, it says, where is tangent radical 3? All right, so radical 3 is going to be approximately 1.7. So you can always put in a calculator if you're trying to figure out where is it going to be on my chart. So it's going to be just under 2. All right, now again, I want you to think about how often does it repeat itself in a cycle. Okay, only once. So you'll notice from negative pi over 2 to pi over 2, it only happens once. Okay, so for every cycle, it only happens once. So Now, tangent of radical 3, we need to think about our triangle again, all right, where we have 1, radical 3, and 2. I have pi over 3, nope, this is pi over, yeah, that's pi over 3, pi over 6, okay? So pi over 6 is, if I were to do the tangent, is opposite over adjacent, which is 1 over radical 3. That's not what I'm looking for. Pi over 3 is radical 3 over 1. So this is pi over 3. So my answer is going to be t equals pi over 3 plus k pi. That's super important that it's plus k pi because it repeats itself every cycle. So k is any integer, so at 1 pi, 2 pi, 3 pi, 4 pi, negative 1 pi, negative 2 pi, and so forth, it will be repeating itself. And that is it. This is all your homework is. Okay, you can look at your graphs in the book. Okay, you can draw your own graphs, however you want to do it, but you need to give me these values. Okay, some of them are going to be easier than others. Make sure whether or not you know if it's 2 values or 1 value, and you do that by drawing a line. So it might help to actually draw the pictures so you have the lines. I think that's it. Okay, I'm going to stop now. For those of you who think you get it, go ahead and move on. I'm actually going to go on just a little longer, go back a little bit, repeat some stuff, and make sure that we have a good understanding of this so that you can do your homework, because it shouldn't be that hard. All right, so let's go back to the sine. The sine wave is, it repeats itself every 2 pi. So because when I did the example here, it's where sine of t is 1. Okay, that's this value here. So just make sure that you know when it repeats itself. So for example, if I had done, 1 over radical 2, that would be a line right here, which would repeat itself twice within there. So you would have to have 2 answers for that. So make sure you know when it's repeating itself. Okay, pay attention to where you are. All right, in this case, it would be just below pi over 2 and just over pi over 2. Okay, so in this case, it would be, if we were looking at 1 over radical 2, pi over 4, and 3 pi over 4. Okay, so make sure that you know where the values are coming from. Negatives help a lot because in this case, we know they're both going to be positive, so they're both going to be in positive quadrants. If we were down here, they would both be negative, so it would be negative quadrants. Again, I'm just trying to get some deeper understanding here if you're looking for that. Okay, if we go back here, this is the same thing, we just did this example, but see, this is one where we negative, so we knew that these had to be in negative quadrants for cosine, which is quadrant 2 and quadrant 3. All right, we'll go back to the very first example, just to make sure that we have, again, we understand where we're coming from. These had to be in positive quadrants for cosine, okay, and so cosine is positive in both the first and the fourth quadrant, so we know that these had to be positive values, so they had to fall in those quadrants. So these are just some helps to help you figure out where are my values. All right, you should know your unit circle, okay, you should know approximately where they land, and I think you will be just fine on the homework.